Hello everyone, this is Mohsen and this is my final project in CS50 course named Pavement Condition Index Dashboard. So whenever you see PCI, that's short for Pavement Condition Index, a robust web application designed for the road management sector in cities. And this project specifically is for Tehran City. This project isn't just about score, to be honest. It's about translating complex engineering standards into a functional digital tool. The reason that I chose to create this project originated from the first year of my master's, and I remember that in the first year, we performed this entire procedure, calculating distress density, assigning deduction values, and determining PCI. Those are all related to transportation engineering, and that may be challenging for people who are not familiar with this major. Anyway, um, that was performed in the micropaver software. My goal for this final project was to automate this entire complex process. Crucially, while this is a simplified web application, and I know that, the primary focus was to demonstrate mastery of all core principles I've learned in this course. This includes database design, backend logic, web development using Flask, and creating a dynamic, user-friendly front end. Let's go to the backend. The backend is powered by Python and Flask. Its most critical job is the PCI load calculation. This function is built on the core methodology of the ASTM standard, specifically ASTM D6433 standard, utilizing the concept of distress density. That's a significant step up from simple counting. Firstly, I achieve this by calculating the road segments area, I mean length times width, and then calculating distress density. This density value is multiplied by a highly scaled weight. That's a necessary step to ensure even small amounts of high severity distress correctly impact the final PCI score, which ranges from 0 to 100. Uh, all project data from road dimensions to maintenance history is stored in a SQLite database. Uh, we use three main tables, segments, distresses, and actions. The front end is clean, responsive, and multilingual. Not to brag, I try to be. The dashboard is the command center, displaying the average PCI and a dynamic list of segments completed with a visual PCI bar. You can instantly filter segments by their condition, categorized by good, fair, or poor. Um, if we need to add a new segment, we navigate to the Add Segment page. The system calculates the total length and area automatically based on the start and end kilometerage entered by the user. On the segment details page, we see the definitive PCI score and the recommended action like overlay or major rehabilitation. We can also view the history of all recorded pavement failures. Let's go to the add distress page because we're going to focus on the distress type and unit fields. To ensure our data is useful for professional assessment, I implemented granular measurement methods. Notice the distress type and severity are displayed in English, both in English and Farsi. Actually, the Farsi translations actually. And crucially, the unit field is expanded. I think this allows engineers to record pavement flaws accurately. I used a score meter for area-based issues like fatty cracks, millimeter for depth-based defects like rotting, and finally, I should mention meter and count for linear cracks and isolated items like potholes. Um, let's go to the actions list. That is named actions.html file in my project file. Finally, the actions history page allows us to track all repair work. closing the maintenance loop and providing full traceability. About the dashboard again, this PCI dashboard delivers a fully functional data-driven tool for managing payment assets, integrating the complexity of the ASTM standards into a user-friendly web application. And also, I think it demonstrates my command of web programming fundamentals. I know that is so simple. To track the PCI of our pavements, I know that, but as I mentioned, I just wanted to compile all the points that I've learned in this course. Thank you.